Why and exactly how would the U.S. strike Iranian power plants? Here's the scenario. To pressure Iran into keeping the Strait of Hormuz open, the U.S. would go after three main facilities. The biggest is the Damavand power plant, followed by the Sima plant, along with a couple of hydroelectric facilities. But there's a serious logistical problem. Most of these plants are located deep in northern Iran. To reach them, the U.S. would likely need to launch heavy bombers from a base in Cyprus. To get the job done, they'd rely on the B-1 Lancer. These bombers are extremely fast and built to come in hard and low on their targets. Meanwhile, the massive B-52 Stratofortress would deliver the heavy punch, dropping over 90 precision-guided bombs at once. Capable of completely wiping out hectares of energy infrastructure to force the Strait of Hormuz back open, the United States has put together a drastic new strategy, systematically taking down the Iranian regime's power grid. To understand how this unprecedented strike would play out, we first need to go through the target list. Target 1 is the Damavand combined cycle power plant in Tehran province. This is the crown jewel of Iran's grid. Covering 193 hectares on the edge of the capital, it generates a massive 2,900 megawatts. Taking this offline wouldn't just cause a flicker. It would set off massive rolling blackouts across Tehran. Target 2, the Shahid Salimi power plant in Mazandaran province, sitting right on the Caspian Sea coast. This thermal plant puts out over 2,200 megawatts. Target 3 is the Shahid reshape plant in Kazvin province, generating over 2,000 megawatts. Knocking this facility out would paralyze the critical industrial zone of northern Iran. There are other large assets, but they come with serious collateral risks. Hydroelectric dams in Khuzestan province, like Shahid Abaspor, produce huge amounts of power, but hitting them carries the extreme danger of catastrophic civilian flooding. Then there's the Bushehr nuclear power plant on the Persian Gulf coast, Iran's only operational civilian nuclear reactor. Striking it would risk deadly nuclear fallout and draw severe international condemnation. Here is exactly how that strike would happen, in three distinct stages. This is stage 1, the blinding. It begins before a single U.S. aircraft even enters Iranian airspace. Tomahawk cruise missiles are launched from the Arabian Sea. They fly dangerously close to the terrain, weaving through the valleys of the Zagros Mountains to blind Iran's early warning radar arrays. At the same time, F-35 Lightnings slip undetected into contested airspace. Using their advanced sensor fusion, they locate Iran's S-300, and indigenous Bavar 373 surface-to-air missile batteries. From safe standoff distances, they fire a GM-88 anti-radiation missiles, locking onto radar signals and destroying the air defense network from the inside out. Then comes stage 2, the penetration. With the air corridor briefly cleared, heavy stealth bombers like the B-2 Spirit make their silent approach toward Tehran province. They aren't carrying nuclear payloads. Instead, they carry heavy weapon packages built specifically for precise industrial destruction, like the JDAM weapon system, creating multiple explosions, as many as 80 of them in 60 seconds. Stage 3, the cascading failure. This is stage 3, the strike on Damavand. The objective isn't to flatten the entire 193-hectare compound. That's inefficient. The goal is to cause catastrophic mechanical failure to the hardest-to-replace components. Bombers drop 2,000 pounds GBU-31 JDAMs, threaded precisely through the roofs of the main turbine hulls. The massive blasts shatter the custom-built generator shafts and destroy the step-up transformers outside. As Damavand and secondary targets fall offline, the sudden massive drop in grid frequency causes automated safety systems across the entire Iranian network to trip. The result is a devastating cascading failure, plunging military command centers, industrial bases, and major cities into total darkness. Because the Shahid Salimi power plant sits far to the north, right along the edge of the Caspian Sea, reaching it means cutting deep into Iranian airspace. This is where the U.S. Air Force would call in the B-1B Lancer. Sweeping in over the Alborz mountain range, the B-1 would unleash a rapid-fire sequence of 2,000 Del BJDAMs. The precision munitions would tear through the plant's thermal generation infrastructure, crippling the 2,200 megawatt facility within seconds before the bomber hits the afterburners and disappears back over the horizon. Operating from safe high-altitude standoff ranges, the B-52 acts as a flying arsenal. Once fighter jets from Cyprus and other regional bases have successfully taken out any remaining surface-to-air missile threats, it methodically drops a heavy, sustained payload of precision-guided bombs, systematically destroying the plant's massive cooling towers, transformer yards, and boiler houses. Worth noting, it can also carry up to 27 conventional bombs in its internal weapons bay. These can be Mark 82 unguided weapons, dropped in rapid succession across a wide area without any guidance system. But how do you hit an underground nuclear enrichment plant, the underground nuclear programs? The problem is these aren't just buildings you can level. They're heavily reinforced underground structures buried deep beneath solid rock. If you wait too long, the enemy moves their most critical assets, nuclear enrichment materials, into unreachable bunkers. So the military drops specialized deep penetration munitions, massive bunker busters designed to cut through the earth and detonate inside the mountain. It's a surgical and violent process meant to completely collapse the underground networks, setting the nuclear program back by decades. By week 4, you've achieved full air superiority. The large-scale bombing campaigns stop, and the hunting phase begins. F-22 Raptors and F-15s take over, aggressively covering the entirety of Iranian airspace. They are kept continuously in the air by a steady rotation of aerial tankers. It becomes a highly coordinated hunt. Targets are spotted by Space Force satellites and Central Command, with the data fed directly to the fighters, usually directed by an E-2D Hawkeye command aircraft. The core strategy here is to avoid a ground occupation entirely. Instead, the U.S. controls the battle space from above, striking from the air the absolute moment a target shows itself. They are specifically hunting for missile launchers, which are typically hidden away in concealed underground facilities. To keep the pressure constant, MQ-9 Reaper drones patrol the skies around the clock. The moment the enemy rolls out a ballistic missile to attempt a launch, those Reapers are already waiting overhead ready to take it out with Hellfire missiles. But why use 3 different strategic bombers? The B-1B Lancer, known as the Bone, this supersonic heavy hitter carries the largest payload of any U.S. bomber. It can dash in at high speed and low altitude to deliver massive volleys of cruise missiles or satellite-guided bombs to clear the path. And finally, the B-52 Stratofortress. It may look dated, but don't underestimate it. It operates as a flying missile truck, capable of firing long-range cruise missiles from hundreds of miles away, well outside the reach of Iranian air defenses. Here's how the layered attack works. The first wave strike involves the B-2 stealth bomber going in to destroy Havalia air defense systems like Zal-Stold-Foro Triumph and other surface-to-air missiles, effectively disabling them using its stealth capability. Next, the B-1 Lancer flies at very low altitude toward enemy targets to take out older anti-aircraft guns and missiles. This clears the way for conventional aircraft like the B-52 Stratofortress, which can then come in to strike critical infrastructure without facing anti-aircraft threats. This is exactly why they need both the B-2 stealth bomber and conventional bombers, because there are only 19 units of the B-2 Spirit currently in service.